Hello guys, my name is Ash Bisoy from class 8E, and today I will be teaching Factorization chapter 14 of our class 8 textbook, and which is a continuation of algebraic expressions and identities chapter, where we'll be studying what is factorization, what are factors, how to factorize them using common multiples method, using regrouping method, and using identities, and then we'll be learning how to divide expressions. So let's get started. First, as we know, what are factors? Factors are the coefficients or numbers when multiplied give a term. For example, the term 5xy has three factors, which are 5x and y. So how is 5xy formed? We multiply these factors to give us terms. So what are terms? Terms is any multiplied answer of factors which is a part in any expression. So in this chapter we'll be studying how to find factors of expressions like 2x plus 4. So now we know how to find factors of a single monomial, but we have to find for binomials, trinomials, and more polynomials. So that is what we'll be studying in this chapter. So first of all, we will be learning how to solve using common factors. So first we have to know what is factorization. So factorization of any algebraic expression means that expression can be written as product of factors. For example, how this 5xy can easily be shown as the multiple of 5x and y, the product of 5x and y. So likewise we can show 5x square y, 5x square y, or 2x plus 1, wait, 2x plus 1, etc. These can be shown easily, wait, sorry, 2x, then 3x into x plus 1, etc. can be shown as factors, as terms that we get after multiplying. So here we can easily see that 5xy we get when we multiply 5 x, x and y. So we, from seeing this number we can find out its factors. From 2x the factors are 2 and x, so we can easily find from seeing the number. And 3x into x plus y, the factors are 3 x and x plus 1. So these are the expressions in which we can which show as they are multiples of the factors. But there are many expressions from which we have to solve or factorize to find their factors. So that is called factorization. So factorization means showing the expression as the multiple of its factors is known as factorization. For example, now we will be learning from common factors method. For example, now we take 2x plus 4 equals to, we can see here that 2x equals to 2 into x, and 4 equals to 2 into 2. So here we can see 2 and 2 are common, and how we have been learning with playing with numbers and etc. From grade 6 we can take out the common factor out 2, and then we can put x plus 2. So it is, now these two are the factors. So the factors of 2x plus 4 are 2 and x plus 2. So this is the way how we find factors using common factors method. And we have been learning, we have learned in the algebraic expressions and identities chapter that if you open these brackets, you have to multiply 2 and x and 2 and 2. So when you multiply, we get this answer. So this is how it's just opposite of solving the solving a monomial with a binomial. So now we will be seeing another example with, using common factors. So for example, we will take 10a square b plus 12ab square. So you have to find the common factors of these. So 10a square b equals to 2 into 5 into a into b. Now for 12ab square, it will be 2 into 6 into a into b into b. So here we can see that 2 and 2 are common, a and a are common, B and B are common. So here we can take 2AB outside. Then we have here 5A. So it will be 5A plus here we have 6B. That is 6B. So these are the common factors. The common factors are 2, the factors are 2A, B and 5A plus 6B. And when we solve this, we will get this answer. So this is using common factors. Now we'll be seeing using regrouping terms. So using regrouping terms, we'll take an example now. That is 2xp plus 2p minus 3q plus, um, we'll keep it simpler, 2p plus 3x minus 3. So when we solve this, we'll get, we can see here that the first two terms have a common factor, that is 2p, 2p, 2p. Here we can see that the common factors are 3 and 3. So we can see that there is no a single common factor. There are two common factors for two group of terms. So that's why you solve these two as different expressions. So first you have to solve 2x plus 2p. So 2p will be out as the common and this will be x plus 1. It's x plus 1 because now there is nothing left here. 2p is fully taken out, so there is nothing, that is, then it will be 1. Then plus, here we'll take 3 out and here also it will be x plus 1. You can see here that this is 3, and as we know, if 3 is completely taken out, then it will be 1, because as we know 3 when we write 3 as factors, it will be 3 into 1. So when we if we have to write it, it will be 2x into p equals to 2 into x into p. Then if we write 2p equals to 2 into p, then if we write 3x equals to 3 into x. We have learned this. We have to write it like this. Then we can find common factors here. Then this and this will be common factors. So here is x1 and here also there will be x1 you can write. So this is how we do. But as we know already the common factors, we just take it out. So now here we can see that x plus 1 and x plus 1 are common in both. So we'll take it as 1 and this will become 2p plus 3 into x plus 1. These are the factors. So there are two factors. The first one is 2p plus 3 and second one is x plus 1. And when we solve it as binomial into binomial, how we have learned in algebraic expressions and identities, we'll get this answer. So now let's move forward. So now we will learn of factorization using identities. We know the four identities we have learned in the last video, in the last chapter. So the first identity we know is a plus b the whole square equals to a square plus 2ab plus b square. We know this formula. So for example, now if we get x square plus, take example 8x plus 16. So here we know that the first term, that is a, is x. As we can see here, it's a square, so this is x square. So this will, x will be taken as a. So a equals to x. Now what is b? B will be the square root of 16, because here we can see it is b square. So the square root of 16 will be 8. So b will be taken as 8. And 8x means 2 into, um, sorry, really sorry, 16 square root is 4, so the answer will be 4. And 8x means 2 into x into 4, which is equals to 8x. So here we get that b is 4 and a is x, so we can solve it as a square plus 2ab plus b square equals to x the whole square plus 2 into x into 4 plus 4 square. We have to substitute the values. So after substituting the values, we find that it's x plus 4 the whole square. So first we write the identity a plus b the whole square equals a square plus 2ab plus b square. Then we write the question x square plus 8x plus 16. Then we have to find the values of x for the a and the b. And for you finding that, we know x square. So we have to take the square root. The square root of x square will be x. So a will be equals to x, and the square root of 16 will be 4. So here we know it's a square and b square. So for finding the value, you have to do square root, the inverse way, in which we will find that b equals to 4. And for verification, we'll use this 2ab. So here we have multiplied 2 into x into 4, that will be 8x, which is here. So now we find the values, and then we will substitute the values here. So a equals to x as it is, then 2 into a into b, that is 2 into x into 4, that is 8x, and then it will be 4 square using b square, and that will be 16. So we can see that everything matches as it is. So that's why the answer will be x plus 4 the whole square. Now we'll be seeing another example. Now we'll be seeing the identity number 2, that is a minus b the whole square equals to a square minus 2ab plus b square. So when we use this formula, we have to use it the same way how we have learned for the last identity. So take the same example. Now, okay, we'll take a different example then. 4y square minus, for example, we'll take 12y plus it will be 9. This is the one given in the textbook, so we'll use the same way. So we can see here that 4y square, so we have to find the square root of 4y square. 4y square square root, this will be 4y square square root equals to 2y, as square root of 4 will be 2, and y square root of y minus, it will be we'll take it as 2 into 4, sorry, 2y, and now we'll be finding the second term. Second term will be the square root of 9, so plus square root of 9, so square root of 9 will be equal to 3. So the second term, that is b, is 3. Now we get a equals to 2y, b equals to 3, and 2ab will be 2 into 2y into 3, that is equal to 2 into 2 into 4, 4 into 3, 12, 12y. So everything satisfies now. We can see that a square minus 2ab plus b square equals to a square will be 2y the whole square minus 2 into 2y into 3 plus, sorry, it's 3 plus 3 square. So now we get that it's a minus b the whole square. So a is 2y and b is 3 minus 3. So it's 2y minus 3 the whole square. Again, summarizing it up, the second identity is a minus b square equals to a square minus 2ab plus b square. So we get the question 4y square minus 12y plus 9. We have to find out the square roots of 4y square and 9 using the formula as it's a square and b square. Finding a and b will be the square root of a square and b square. The square root of 4y square will be 2y, and the square root of 9 will be 3. So finding that, a square will be 2y the whole square, and then 2ab will be 2 into 2y into 3, and 9 square root will be 3. So it's 3 square. So we find that a equals 2y, b equals to 3. So it will be 2y minus 3 the whole square. So this is how we find it. It's the same method as before, just it's that the symbol here is different, here is different. Now we go into the third identity. Now the third identity is a plus b into a minus b, that is a square minus b square. So for example, we'll be taking as, for example, 36x square minus 20 minus 25, for example. So here we can see 36x square will be a square and 25 will be b square. So to find out the square root of 36x square will be 6x, as the square root of 36 is 6, and x square root will square root will be x. So 25 square root will be 5. So here we get it. So a equals to 6x and b equals to 5. So here we get it that a plus b into a minus b equals to a square minus b square equals to 6x plus 5 into 6x minus 5 equals to 36x square minus 25. This is the answer. The answer is 6x plus 5 into 6x minus 5. These are the factors of this expression. Now we'll be going forward and seeing some complicated problems that will be coming forward. So now coming forward, you can see a question here. That is 4p square minus 8pq plus q square minus c square. So now we can see here that if we take c minus c square out and take these three terms, we can see that these three terms are in the form of a minus b the whole square. So these three terms can be written as a square minus 2ab plus b square. So we can also find here that equals to first one, the square root of 4p square, then minus 2 into something like that, isn't it? Sorry for the mistake, it's 4p cube. So if we solve it like that, it will be 2 into something plus the square root of q square, and then we close it, then minus c square. So this is how we form it. Now finding the square root, if we find the square root of 4p square, it will be equals to 2p. So we find out a equals to 2p. Now b will be the square root of q square, that is q. So we get it as b equals to q. So now we can solve it. It will be equals to, we can solve it as if 4p square will be 2p minus 2 into 2p into q plus q square, 2p the whole square, and this will be q the whole square minus c square. Now when we solve it, we will get it as 2p minus q the whole square minus c square. Now this question is also in the form of, now this expression 2pq square minus c square is in the third identity, that is a square minus b square. So this will be equals to a plus b into a minus b. So now we can see that 2p minus q square minus c square is in the form of a square minus b square. So we know that that a is 2p minus q and b is c square. So the answer will be 2p minus q, 2p minus q plus c into, sorry, into 2p minus q minus c. So this is the expression that we get. It is 2p minus q, that is a, plus c. So this is in the a plus b, and 2p minus q minus c, that's a minus b. So which will equals to, the answer is now 2p minus q minus c, and this will be 2p p minus q plus c. This is the answer that we get. So we can see here that this question requires for the first the factorization of a minus b the whole square, and then the factorization of a minus b, a square minus b square, factorization. So here we use the identity number 2 and identity number 3 for the factorization, and we get the terms are 2p minus q minus c and 2p minus q plus c. These are the answers. Now going forward, we have another really complicated questions that can come. Now the question ahead of us is very small one, p to the power 4 minus 144. But this is also a very big answer you will get. For first method is we'll write it as the identity we'll be using is a square minus b square equals to a plus b into a minus b. This is the identity. So we'll write it as p square to the power square the whole square minus 12 to the power 2. So this is the answer that we get after doing the first step. So after solving this, we get it as, now we'll be using it like this. So it will be p square minus 12. Wait, we can make this more complicated. For example, now we will take it as, for a minute, wait, 256. If we take it as 256, we'll get more interesting things. So we'll take it as p square to the power a whole square minus, this will be 16 square. So here we'll get it as p square plus 16 into p square minus 16. Now p square minus now p square minus 16 can be written as p to the power 2 minus 4 to the power 2. So this is again in the method of a square minus b square. So this can further be written as p minus 4 into p plus 4. So the answer will be p square plus 16 into p minus 4 into p plus 4. These are the factors. The factors of p square minus 256 will be p square plus 16 into p minus 4 into p plus 4. So this is how we get, this is a complicated question that we can see. Here we are using a square minus b square twice. And as much as possible we'll be doing till there is no more further we can reduce it. Now we'll move forward. Now we'll be learning the last and the final identity, that is x plus a into x plus b equals to x square plus a into a plus b into x plus ab. So for factorizing expressions which will be in this format is called sum and product rule or splitting the middle value. So now for example we take x square plus 5x plus 6. So we know that a into b. So we know that a plus b now equals to 5 and a into b equals to 6. So we have to find a and we have to find b. How are we going to find this? So we know that the a and b are factors of 6. So we'll find out the factors of 6. 6 will be 1 6, 2 3, 6 1. These are the factors. So 6 and 1 and 1 and 6 are same. So these are the factors. Now going forward, let's try one of them now. So now we'll take 2 and 3 for example. If a equals to 2 and b equals to 3, let's try it out. 2 plus 3 equals to 5 and 2 into 3 equals to 6. It satisfies the problem. We get it 5 here and we get the 6 here. So we can see here that 2 and 3 are the factors of a and b. If we take 6 and 1, 6 into 1 will of course be 6, but 6 into 6 plus 1 will be equal to 7, but here it is 5. So this is why it does not satisfy. We have to find the factors such that it can satisfy 5 and 6. So that's why there are 2 and 3. Now if we found out 2 and 3, so now the question will be like x square plus the factors are 2 plus 3 into x plus 6. So now we'll be solving them. So this will become x square plus 2x plus 3x plus 6. Now we'll be doing the other method of factorization. We found out the factors. The factors here are 2 plus 3 and x. So when we multiply, it will be 2x plus 3x. So we can find here that the common of the x square and 2x common is here x. So x will come out as it is common in both, and then it will be x plus 2. We can see here x plus 2 is out, and here the common is 3. So 3 will come out, and we will use it x plus 2. This is regrouping the terms. Now we regroup the terms, and now we can see that x plus 2 is common in both. So we will take it as x plus 3. So it will be x plus 3 plus x plus 2. Now we can find out that x plus 3 is x plus a. X are same, and 3 into a. So a will be 3. And x plus 2 is same as x plus b. So b will equal to 2. So everything satisfies as it is. So summarizing how to do this, the fourth identity. So fourth identity is x square plus a plus b into x plus ab. So here a and b are such two factors that when added they will give us 5, and when they are multiplied they will give us 6 according to the question. So we have to find the factors of 6, as when they multiply give us 6. So we get here two groups of factors, and here if we take 1 and 6, when they add they will give us 7, but here it is 5, so they don't satisfy. Now we take 2 and 3. When we multiply 2 and 3 we get 6, and when we add we get 5. So 2 and 3 are satisfiable. So here 2 will be a or b, 3 can be a or b, so that doesn't matter. Now we solve it. So x square plus 2 plus 3x into x plus 6. Now keep on factorizing. We get x square plus 2x plus 3x plus 6. We find the common factor of the first two terms. It is x into x plus 2, and the second two terms we get 3 into x plus 2. Here we get common x plus 2, so we keep it aside and we take x plus 3 as a common. So here we get the terms as x plus 3 into x plus 2. This is the way how we have learned regrouping the terms. Now we will move forward. So here we can see that negative 6 into 2 will give us negative 12, as one is negative and one is positive. So when negative into positive will give us negative, and negative 6 plus 2 will give us negative 4, and that is what is given here. So when we solve this, we get to know that a equals to negative 6 and b equals to positive 2. So we solve it, it will give us z square minus, we'll take it plus here, as this will be taken as 6 plus positive 2 multiplied with y. Where is it y? Sorry, it's not y because it cannot happen. That should be z. Sorry, this will be z, and this will also be z, and then this will be minus 12. So when we take it like this, it will be equal to z square minus 6z plus 2z minus 12. Now we solve it. So this will z will be taken as common out, z, and this will be z minus 6, and this will be taken as positive 2 will come out, positive 2, and this will be taken as z minus 12. The minus will remain as minus because it's positive that is outside. So when positive into negative will always be negative, so we don't have to change the symbol. Now we can see here that z minus 6. So we can see that z minus 6 is common. So we'll take z minus 6 is common outside, and then this will be z plus 2. So this is another alternative. As we can see here, the first one, we can have 4 ways. Plus plus, or we can have minus here, and here plus, or here it is going minus. So these are the 3 alternatives that we see. Now we will go forward. Now there can be some different type of questions related to x plus a and x minus x plus b, which you cannot find out that in which identity is given. So here we can see that here these three terms are given. Now here we can take the common factor out. The common factor is 3. So when we take 3 out, it will be 3 into m square plus 3m plus 2. So this is the question. Now we can see here that m square plus 3m plus 2, it can be written as the fourth identity. So it will be m square plus now 2 can be written as 2 into 1. So it will be 2 plus 1 into m plus 2 into 1, that's 2. So it will be equals to m square plus 2m plus m plus 2, 1m, equals to m will be taken out and this will be m plus 2, and this here common can be 2 can be written as 2 into 1, 2 into 1. So here 1 can be taken as common out, 1 m plus 2. So we can see here that m plus 2 is common, so it will be m plus 1 into m plus 2. So the answer will be equals to 3 into m plus 1 into m plus 2. So these are the common factors. They are 3 m into m plus 1 into m plus 2. So this is another type of question where the fourth identity can come with more multiples. Now we go forward into division of algebraic expressions. Now going forward to division, we will first be dealing with monomial by monomial, which is very easy. It's just the cutting out method of how we have learned in exponents and powers chapter. Then we come to polynomial by a monomial, and then we'll come to polynomial by a polynomial. So first monomial by another monomial, we'll be dealing with negative 10x square by 20x, which can be written as negative 2 into 5 into x by 2 into 5 into 2 into x. Here x and x can be cancelled out, 2 and 2 can be cancelled out, 5 and 5 can be cancelled out. So here the answer is x by 2, isn't it? X by 2. So the answer will come out as answer will be x by 2. That's what we get. Now for example, another question we can take as, for example, 7x square y square z square divided by 14xyz. So here we can write 7 into x into x into y into y into z divided by 2 into 7 into x into y into z. Here we can see that the answer is 7 can cancel out, x y z. So the answer we get is 1 by 2 into x y z. This is the answer that we get. That is half of x into y into z. So this is how we do a monomial by a monomial. Now we'll be going into how to do a polynomial by a monomial. We can solve these type of questions by two methods. First of them is using the cancellation method that we have seen, and another way is dividing each of the term of the polynomial one by one with 2y. We'll be seeing both of the methods. First method, we'll be solving it like this. We'll do 2 into 2. We'll be solving. We'll first take the common factors out. How we do, so that it becomes more simpler for us. So 4y cube equals to 2 into 2 into y into y into y. Now the another one is 5y square equals to 5 into y into y. Now the next one is 6y equals to 2 into 3 into y. Here we can see that one thing is surely common, that is y. So we can take y out here, y out, and then we can multiply each of the other terms. So here y into 4y square plus 5y plus 6. Now it will be divided by 2. 2y. So after we do this, we can see that we can cut out 2y. So we can cut out each of them. Now for cutting out each of them, wait for 1 minute. We can cut it out as like this, y. Now after y and y are cut out, we get it as 4y square plus 5y plus 6 divided by 2. So now we'll be dividing it as, now we'll be separately we'll divide. So 4y square divided by 2 will give us 2y square. So when we get 2y square plus 5y divided by 2 will be as same as it is 5y divided by 2 plus 6 divided by 2 equals to 3. This is the answer. 2y square plus 5y by 2 plus 3. So how we do it? 4y cube will be written as like this. We will find the common factors of, common factor is y comes out. Then we divide y and y. So we are left with 4y square plus 5y plus 6 divided by 2. 4y square divided by 2 will give us 2y square. 5y divided by 2 will be 5y divided by 2, and 6 divided by 2 will be 3. So we get it like this. Now the other method is using dividing each of the term by 2y. We'll see that. So the other method that we do can make this question easier, but maybe the other question that can come in the exam will make it a bit difficult. So now this will be like 4y cube divided by 2y plus 5y cube divided by 2y plus 6y divided by 2y. Now this is the way we separately divide each of the term with 2y. So we get the answer as, we know that y cube will get cancelled how we have done in exponential powers. So y cube will give us y square, and 4 will give us 2. Here y and y will get cut out, 2 and 6 will give us 3. So equals to 2y square plus y and y will give us y plus 5y divided by 2 plus 3. So we get the same answer by doing it in the other method. Here we do the second method easily, but maybe the other questions can make this method a bit harder, because most of the times you don't get the factors of 2 so easily in the questions. Sometimes if it's given 7y, then we cannot divide it perfectly, we'll get remainders left. So that is why you write in the fractional form how we have done 5y squared divided by 2y. Now we'll be going to the other, that is polynomial divided by a polynomial. Going forward to dividing polynomial by polynomial, there are normally two methods. The first one is cancellation method, and the second one is long division method. So we'll be seeing first how to do it in cancellation method, how we have learned. Now we take the example as 7x square plus 14x divided by 2 x plus 2 using the example given in textbook. Now using we get 7x square equals to 7 into x. Now 14x will be 2 into 7 into x. We can find that x and x are common, 7 and 7 are common. So we take the common factors out, that is 7x into x plus 2 divided by x plus 2. Now we cancel x plus 2 equals to 7x. That's the answer. These are the very simple ones. Now we'll be taking another example. For example, the next one. The next example is for 44 x cube minus 5x square minus 5x cube minus 24x square divided by sorry x4 divided by 11x into x minus 8. That's how it is given. Now we take the common factors out. So if we take the common factors out, we'll get it as, for example, now we have to use the identities we have learned. So using the identities, we get it like this. For example, we'll get it as, we'll take the common factor out. Here common factor is x square, so we'll take it like it will become 44x square into x square minus 5x minus 24. Yes, it's like this, 24. So we get it like this. Now we can see that. Now we'll use the fourth identity. So that is x square minus which identity. Now we'll take out the factors. So the factors will be 8 and 3. So we'll take out 8x 8x plus 3x minus 24. We take the common factors out. This will be x into x minus 8 plus we'll take here the common factor 3 into x minus 8. So then we get it as x plus 3 into x minus 8. So we get it as equals to 44x square into x minus x plus 3 into x minus 8 divided by 11x into x minus 8. So we cancel x minus 8 and x minus 8. Then we cancel out 11x and 44x x square. So that's why 11 44 we get it as 4x into x plus 3. That's the answer. 11x 4x into x plus 3. That's the answer. So what do? We find the common factors out of this. So we get 44x square into x square minus 5x minus 24. This is in the method, this is in the identity number 4. We solve it, we get x plus 3 into x minus 8. So it is 44x square into x plus 3 into x minus 8 divided by 11x into x minus 8. Now we cancel them out and we get 4x plus 4x into x plus 3. It is like this. Now we will be seeing the second method. The second method is using long division method, which is really important for higher classes, because in higher classes we can't do this method, the cancellation method, as there will be more bigger and bigger polynomial questions. So for example, we'll take the first question itself, that is 7x square plus 14x divided by x plus 2. So 7x multiplied with x multiplied with what will give us 7x. So we'll get it as 7x. So x into 7x will give us 7x square. So we'll minus it. We'll use normal division method, 7x square. Now there's 2 left. We have to multiply with this 2 with 7x. So let's do it as 2 into 7x square. We'll get it as 1 minute. Now we'll multiply this 2 with 7x. As 7x is the quotient, we have to multiply these both with 7x. So when we multiply 2 with 7x, we get 14x and 0. We minus it, and when we minus 7x square plus 14x square minus 7x square plus 14x square, we get 0. How we do normal subtraction? We get 7x. So the answer is 7x. And when we did cancellation method also, we got the answer 7x. Now we'll be doing some big questions. One question of finding out how we use it for big, like trinomial divided by binomial, such questions. So we'll do, the question is x. The question is, take x cube minus 4x square plus 2x minus 3 divided by x plus 2. So when you do this, we have to multiply x with something that gives us x cube. That's x square. So when you multiply x with x square, we get x cube. Subtraction. Then we have to multiply 2 with x square minus we get 2x square. Now we are multiplying, so the sign will change, it will become positive. So here we get 0 and here we become negative 2x square, and we will get this down plus 2x. So when we get this down, you have to multiply x with something that we get negative 2x square. So minus x with 2x. So we get will minus 2x square and plus, so the sign will change. Again, it will become additive inverse. Sorry. We'll do additive inverse. So again the sign will change as we have learned in the last chapter when we do when we divide, and 2 into negative 2x will give us negative 4x. That's what we get. 1 minute. Let me see if there's some error in this question. Sorry sir, there's an error. So now we see here that this is positive, so here there is negative, so the sign changes. This will become negative 6 cube and this will become negative 2x square. So when we get negative and negative, the sign changes here. This will become negative and this will become also negative, so the sign changes. Now positive x cube with negative x cube will give us 0, so here it will be 0 and this will become negative, so the negative 4x square and negative 2x square will give us negative 6x square. So now we have to multiply x with 6x, negative 6x, so it will give us negative 6x square. And then when we multiply, and then when we multiply 2 with negative 6x, we get negative 12x. So till here we have done the question. Now again here we have negative, so the sign will change. This will become positive and this will become also positive, so the sign changes here. Now again this will become 0 and this will become positive, so this will become plus 14x. Now 14x we get 3 here down, so this will become minus 3. Now 14x minus 3, we have to get x plus we will multiply with 14. So x into 14 we get plus 14x here, and then when we multiply 2 with 14 we get plus 28, and then we solve it. Again negative here, so the sign changes. This will become negative and this will again become negative, so this will become 0, and negative 3 and negative 28 will give us minus 31. So that's the answer. We don't include 0 actually anywhere, so the remainder will be negative 31 and the quotient will be x square minus 16x plus 14. So again summarizing how to do the long division method, we have x plus 2 as the divisor, and dividend is x cube minus 14x 4x square plus 2x minus 3. So we have to multiply x with something that gives us x cube. So when we multiply x with x square, we get x cube. Then we multiply 2 with this x square again and we get 2x square. Then we have to minus it, and for subtracting we have to do the additive inverse as we have learned. So for additive inverse, this will become negative 6x cube and this will become negative 2xy. So when we add this positive and negative, we get 0, and when we add this negative and negative, we get negative 6x square. Then we take this 2x down, so we get negative 6x square plus 2x. Now again we are going to do the same way. X into negative x square x 6x will give us negative 6x square. Then 2 into negative 6x will give us negative 12x. Now again subtraction, we'll do again additive inverse, and here to become positive and positive. So negative 6x square with positive 6x square will give us 0, and here plus 2x with plus 12x, this is 12 here, plus 12x will give us plus 14x. Now again the same method, x into plus 14 will give us plus 14x. Then we have to multiply 2 with 14 will give us 28. plus 20. Now we're going to take 3 down, so it will be plus 14x minus 3 minus plus 14x plus 28. Now again subtraction, we have to change the symbol, it will become negative 14x and this will become negative 28. Now plus 14x minus 14x will give us 0, and then minus 3 plus negative 28 will give us negative 31. So that's how we solve it. Now after this is solved, there is not a big part left, it's just finding an error, and we can find errors in algebraic expressions, in factorizing, using the rules we have learned. The first rule that we have is that every term has a coefficient 1. So if there is any term, for example x, it is actually 1x. If we have y, it will be 2y. I mean, sorry, it will be 1y. L will be 1L. X again will be 1x. So it's just like that. So we can't, if it's only x, we can't think it's 0x. This is wrong. So this is an error. When there's only x written, that doesn't mean it's 0x. That means it is 1x. So when we are doing addition or subtraction, we should not forget this 1 over there. So this is the first error that is told. We should avoid this error. The second error is remember to make use of brackets while substituting a negative value. That's what we have learned in the identities. Now if for example there is minus a plus b, so when we put this in bracket, we have to put this negative minus a minus b. So when we put it in bracket, we have to change the value, because now for example we get it like minus a minus b. Now solve it. When we solve it, this will be 1 here, there's nothing left. So when we multiply 1, negative 1. So negative into negative, we have to multiply with negative symbol, that will give us positive. So it will be a plus b. That's how we get it. But here negative a into negative 1 into a will give us negative a. So that's how we get it. Now you're doing the same method the opposite way in factorization. We have to do negative a plus b. We have to do minus into a minus b. That's what is told in the textbook, that when we are using brackets, we have to take this very carefully. Now, the third one is, remember when you multiply the expression enclosed in a bracket by a constant outside, each term of the expression has to be multiplied by the constant. This is what we learned in the last chapter, algebraic expression, that if any constant is outside, like for example, any constant or any variable also with x into 3 plus x, you have to multiply x with both the values. Then only you can open the bracket. That's 3x plus x squared. That is how it happens. So that's why it says that whatever is outside the bracket, the term has to be multiplied with whatever is inside the bracket. Then only the brackets can be closed. That's the first one. The next one is, remember when you square a monomial, the numerical coefficient and each factor has to be squared. So that's why in the identities, this error should not be done. That for example, a square, sorry, a square means anything. For example, 2b square. A square doesn't mean that it should be 2b square. It should be 2b the whole square. 2 has to be square and b has to be squared. So it should be 4b square. That means it's a square means every factor of the term has to be squared. So it will be 4b square and not 2b square. That's what is told as the fourth error that's done. Now, sixth one is, make sure before applying any formula whether the formula is really applicable. That's what we have to know. For the first identity, like it is that is a square plus 2ab plus b square. Here we can see that the first and the last terms are square. So if the expression has the last and the first terms are square and the middle term as the product or as the multiple of 2, then then it can be the first identity. If it is second identity, it should be a multiple of a into b, and the middle term should be a plus b. That's the second one. So that's how we have to first find if it is actually applicable for that identity or some other identity. That's really important, because if you mess it around, you will not get the proper factors. And last I find is, while dividing a polynomial by a monomial, we divide each term of the polynomial in the numerator by monomial in the denominator. For example, this is a common mistake. Now, for example, we take it as a plus 5 by 5. Some people cancel 5 and 5 and tell the answer is a. Some people do it as a plus 5 by 5, just separating it out and make it a plus 1. This is totally wrong. It is a by 5 plus 5 by 5. So that is a by 5 divided by 5 equals to a by 5 plus 5 by 5. So the answer will be a by 5 plus 1. That's the answer, not these. So this is another issue that we do. So these errors should not be followed. And these type of questions can be asked for error correction. So here our chapter 14 factorization ends, and I hope you liked it. If you liked it, then please like the video. This is a really important chapter, and will come for high mark questions. Thank you.